Okay, so this is the homework. Alright, so question 1 was, without using a calculator, find the value of sec 5 pi over 3. Alright, did you get an answer for that one?
Yes, I did. I got 2.
Yeah. So that would be 1 over cos 5 pi over 3. 5 pi over 3 is a known angle, isn't it? It'll be in the 4th quadrant. So therefore cos will be positive in there, and it's a half, and then 1 over a half is 2. Okay, very good. Question 2 then. Answers in radians for arc sine, so inverse sine, minus a half. So we're looking for the angle this time. Malika, any answer there?
I got negative pi over 6.
Yep. So in other words, a translation of what this says is sine of an angle, x, would be negative a half, isn't it? So therefore, and do they say? Okay, so therefore it's between how did you get negative a half, Malika?
I just
So you just, because it's a known angle, you just said that x was minus pi over 6?
yeah, is that not okay?
Why is it minus pi over 6?
Because it's minus a half. I don't know.
Okay. Anyone explain, maybe Rigel, why is it minus pi over 6? Just because it's minus a half?
Well, there's an identity with sine and cosine. If sine x equals negative something, then that I guess. Well, I would say that the negative half would be on the bottom, and my initial answers would have been like my initial answers would have been like 7 pi over 6 and 11 pi over 6. But since it's negative a half, you're going the opposite. It's like the opposite direction. So it's just negative pi over 6 because you're subtracting from 2 pi.
Okay, yeah, so half would be down here, so you could use pi over 6 as a reference angle, pi over 6 here, which means all the way around to here would be, as you said, well, that'd be 7 pi over 6, and then all the way around to there would be 11 pi over 6. So why are we getting negative pi over 6? Why not 7 pi?
Because they're not giving you a domain. They're kind of just giving you at this point what is the angle in radians.
Okay, well then is the answer then pi over 6, is it?
If they give you like from 0 is less than or equal to x, which is less than or equal to 2 pi, you can say 7 pi over 6 or 11 pi over 6. But since it's just asking you the angle in radians of sine x equals negative half, it's gonna be below. It's gonna be in the 3rd and 4th quadrant. So it has to be negative pi over 6.
But if it's the 3rd and 4th quadrant, it's 7 pi over 6 and 11 pi over 6.
No, just negative pi over 6.
Just negative pi over 6. Just
and they don't give you a domain, yeah.
Because they don't give you a domain, you don't do this as we do normally. You just jump straight to negative pi over 6?
Yeah, I believe so, sir.
You believe so? Okay. I think the reason is more got to do with what we talked about on Thursday. Can't remember. Perhaps Wednesday. I can't remember which day it was. Anyway, remember the domain is limited and the range is limited when we're dealing with arc sine, isn't it? So sine, remember, we only take from negative pi over 2 up to positive pi over 2 for this. So it's, remember we did that. So that's where the angle has to lie in order for it to have an inverse, remember? And therefore, that is why it's minus pi over 6. It's because this one, it's not, and that's why it's not 11 pi over 6. Because when we deal with arc sine, it has to be within this range, yeah. All right, I don't know. Hopefully that made sense. Question 3 then, we had a nice little solve here. Root 3 cos x cosec x, I think. Yeah. Plus 1 is equal to 0. All right, Raja, what'd you get for that one? Final answer?
Question 3, 2 pi over 3 and 5 pi over 3.
Yeah, I'd agree with that. Okay. I think, so this would be cos over sine, won't it? Because that's root 3 because of the identity, or the meaning of cosec x, if you want. So I'll just put in an extra step. So you end up with, and when that one, subtracted from both sides, you ended up with minus 1 divided by root 3, and of course cos over sine of x is not tan of x, but if you
Cot?
yeah, it's cot, yeah. But to get a known angle, perhaps tan of x is the way to go. So I'm gonna get the reciprocals of both these because the reciprocals will also be equal. So then I use tan x. You could call it cot, yeah. So that's minus root 3. And then where is tan at negative root 3? So negative root 3 will be in, so it's either this quadrant or this quadrant, isn't it? Because 1 of sine and cos is negative. I'm not sure which. So the reference angle is pi over 3, which means in this quadrant, that's going to be, from there's going to be 2 pi over 3. And in the last quadrant then, which Rigel got correct, is 5 pi over 3 if we did 2 pi take away pi over 3. All right, not going too bad so far.
So-
Yes?
So if tan x equals minus root 3,
Mhm.
why is the reference angle pi over 3? Is that just like the one we're supposed to know?
Yeah, it's from that table we were supposed to know. So we really have to be able to recreate this table at a drop of a hat. So yeah, so do it so the angles increase, which means the sine of the angle is also going to increase. So think of it 1, 2, 3, if you want to write it like that. And they're all over 2. And then think root 3, 2, 1. Okay, and then to form tan, you just do sine over cos. So 1 over root 3 here. Root 2 over 2 is 1, and root 3. So there is our reference angle down here, the one that came up here. So yes, we do need to know it off by heart. You do need to either have this in your head or have a method of recreating it during an exam. Otherwise, yeah, you'll struggle in a lot of these questions. So yeah, do know it off by heart, yeah. All right, so question 4, part F, wasn't it? So we had 4 sine squared alpha minus 4 all over 8 cos alpha. All right. Dai, what did you get for this one? This is simple.
I got negative cos x over 2.
Okay. Anyone get anything different there?
Negative cos x over 2 as well.
Yeah, so it's negative, well, alpha, I think, but yeah. Yeah, so perhaps you can factor out 4, and then you're left with the, this is going to be 1 minus sine squared alpha, so you go minus, or factor out minus 4, wouldn't you? And you're left with 1 minus sine squared alpha, trying to form that identity, because that will diminish the number of terms, because we know that is cos squared alpha over 8, and that'll make causes here. So you get minus 4 cos squared alpha from our formula booklet, 8 cos alpha. So one of the causes is going to disappear, and that's going to be a half. So a half cos alpha, or cos alpha over 2, negative cos alpha over 2. Yeah, sweet. Very good. All right. Question 5. Which I don't think was particularly easy, if I recall. Question 5 asked for if sine alpha is negative 3 over 4 and alpha lies between pi and 3 pi over 2, isn't it? Okay, so, okay.
Sure.
Yeah.
Sure.
Yeah.
I had to do like from part A to F because I think we needed the previous questions to apply to the next question for this.
No, well, you didn't have to. You could have. You didn't need to do it the way they've laid it out. You just do it the way you want to do it. Do it as much as you need to do, as we'll do now in a second. Malika, what did you get for this one?
So this one was actually really confusing. So I don't think I got the right answer.
Yeah. Okay. Okay. But I did all parts. Right. So what did you do for this one?
I also think if you went over that, that'd be helpful for me.
Okay. So yeah, we don't have enough information to do this really at the moment. Is right. So first of all, if you ever have sine of alpha, you can always get cos and tan of alpha. If you have that, so you can get cos alpha, which might help. So cos of alpha, if you just make your right angle triangle, cos alpha, well, that's going to be sine is opposite 3 over 4. So we end up with, if you want to call x here, use Pythagoras. 4 squared, take away 3 squared, square root, and I think you get root 7 here for x. All right, so we do have cos alpha as well. Root 7 over 4. Would it be positive or negative?
It would be negative, sir.
Why?
Because when you take wait, oh yeah, because it wasn't because sine alpha is equal to negative 3 over 4.
Does that mean cos alpha will also be negative?
Think so. Or is it because of the domain?
So take into the domain into account, of course.
Yeah. It's in the third
Domain,
quadrant. It's in the third quadrant.
So, Rigel, is it positive or negative?
Negative. Right?
So sine and cos are negative in that quadrant?
Yeah.
All right. As long as you're sure. So I'll change that to negative. Okay. Next on the agenda, I need alpha over 2. So perhaps I can use, now that I know what sine alpha and cos alpha is, perhaps I can use maybe I could use cos 2 alpha. Is 2 cos squared alpha minus 1. And if I use alpha over 2 here, because this is using just cos on its own. Well, that's kind of why I found it. It's kind of hard to find one with just sine on its own, isn't it? If you look at all your identities, let's get my booklet here. Sine is kind of mixed in with cos, isn't it? Cos plus sine here. Sine, cos, sine, that's another one. Cos and sine is the last one. The only one that just deals with cos is this one, so that's quite useful to find cos, which was an easier question, which would have been part E, to find cos. But because we didn't ask part E, we just wanted to get part F. Did I do that on screen? I may not have done it on screen, but hopefully you see that. Sine and cos are intertwined a lot. So in order to find what sine alpha over 2 is, we must first find cos alpha over 2, which, as Badai said, he just did all the parts, so he would have already had this. So cos alpha over 2, let's get that. Cos 2 alpha then is now cos, we're going to use alpha over 2 as our angle. So that means both sides has to change to alpha over 2. Okay. So now twice alpha divided by 2 is just going to be cos alpha, which is exactly what we wanted. Why did we want that? Well, because we know what cos alpha is. Wonderful. So we're saying it's negative root 7 over 4, and that's going to be 2 cos squared alpha over 2 minus 1. All right, let's isolate alpha over 2. So we add 1 to this, which is going to be minus root 7, add 1, so plus 1, and I'm going to make it 4 over 4, plus 4 maybe, all over 4. And that equals 2 cos squared alpha over 2. Now I'm going to divide both sides by 2, so I'll just do that here, dividing by 2, and that makes that an 8, I think. Correct me if I'm wrong. Now cos squared alpha, so cos squared alpha is just the same as cos alpha over 2 squared. So if I square root both sides, I will then have something, perhaps put the 4 first. 4 minus root 7 over 8, the square root of it, is the cos of alpha over 2. Armed with the cos of alpha over 2, we can use any identity then to find out what sine alpha would be. You can use sine 2 alpha would equal 2 cos alpha sine alpha if you want. You could use, let me just show that. So you could use that one. I think it might be easier to use this one, considering we have cos squareds. We know what cos squared is already from this.
Sir, can you move the paper upwards a bit?
This paper, like that. Okay, so I'll do the other bit over here. So I'm going to try and find what sine alpha is. So I'm going to use sine squared alpha plus cos squared alpha equals 1. I'm going to use that identity, but of course alpha is not going to be alpha, it's going to be alpha over 2. So if it's the same angle, it always equals 1 cos squared plus sine squared, because they are like opposites of each other. I already have a value for this from this work over here, or if you did every part, from part E. So you can say sine squared alpha over 2 plus then, well,
Sir?
yeah.
How did you go from cos 2 alpha over 2 just to cos alpha? You
Well,
just pull the 2's out?
Yeah, it's twice the angle and then half on the angle, so it's just the angle, yeah. All right, so that equals 1. Now, what am I going to pop in here for cos squared alpha?
Would you put in negative square root 7 plus 4 over 8?
Okay, so this is square root 4 minus root 7 over 8. And you're saying to put in negative, yeah? Squared.
Well, it's cosine squared. I was saying put in we have it right above you, not the one below. The negative square root 7 plus 4 over 8.
Oh, put it in this?
Yeah.
Oh, okay,
yeah.
Okay, well, we're going to, yeah, so it is it squared, yeah, and it comes back to this, doesn't it? Yeah.
Yeah.
Okay. All right, so sine squared alpha over 2. This squared is this, of course, or you could just do the square root of it, re-squared again, but that's going to cancel out anyway. Which gives us plus 4 minus root 7 all over 8 equals 1. So that's from here. It's what's cos squared alpha was. And then rearrange this. Common denominator, I think you end up with sine squared alpha over 2 is equal to 4 plus root 7 over 8. I think that's what we end up with. It's just the opposite sign, because the 8 over 8, then this would be 8 over 8, and it ends up. And to get the final answer, it's just square root of it. So hopefully that makes a bit of sense. Okay. Malika, you okay?
Yes, okay.
Question 6. Part D, just yes. Okay, so cosec 2x plus cot 2x equals cot x. Find out what x is. Okay, we will. Oh no, that was not find out what x is. It is prove, is it? Show that. Sorry, show that. So we have to get this to look like that. So to show that, I'll better do it. So I turn that into 1 over sine 2x plus, what's that? Const. Plus cos 2x over sine 2x. So I'm trying to make it look like this. Common denominator is already here, so we're already ready to go. So that's 1 plus cos 2x all over sine 2x. That's all good. Gonna have to use some identities here. Gonna turn that into cos. Use this one. Cos squared cos 2 theta is equal to 2 cos squared theta minus 1. Okay. So 1 plus 2 cos squared x minus 1 now. So squared now. All over. And I'll change this one to this one. To sine x cos x. Sine x cos x. The ones are going to cancel. Okay. They'll disappear nicely. There's cos squared here. So one of those causes is going to cancel with one of these causes. So you're going to be left with, and the 2's will divide into each other nicely. So we're going to be left with cos x over sine x. So hopefully that all made sense. That's cos times cos. So one of them is going to go. And that is, of course, cot, not cos, cot x. Okay. All right. So that was a show that. Moving along to question 7, which wasn't. It was a work that out. And you have to do both parts, if I remember correctly. So question 7. A is cos 165 without the calculator, and B is tan of pi over 12 without the calculator. Okay. Rigel, what'd you get for the first one?
Part A. Negative square root 2 minus square root 6 over 4.
Okay. Yeah, that's right. Malika, what'd you get for the second one?
For the second one, I got. Oh wait, I wrote root 4 minus root 3, but basically 2 minus root 3.
Okay, 2 minus root 3. Yeah, I'll do one of these. So this is quite common for this to come up as an exam question. Which one will I do? Let's just do the first one. So just in case you weren't 100% sure, so you make the angle out of known angles. So 165 is cos 120 plus 45. So there's 2 angles I know the values of, and then I use the compound angle identities. So here, compound angle identities, I know what cos alpha plus beta is, and I just use that formula. So I end up with cos 120 cos 1 or 45 minus, so remember that the cos one of these is the opposite, and then our known angles, cos 120. What's the cos of 120, Malika?
Is that just 1/2?
Okay, so our reference angle will be 60. Remember, so think about where 120 is. It's going to be over here. that cos refers to the x-axis, so the x value would be negative over this side, wouldn't it? So it's negative a half. Yeah. Cos 45 then, well, that's going to be in the first quadrant, so that's definitely positive, and that's one of our known angles. You can do root 2 over 2 or 1 over root 2, whichever one you want. Perhaps root 2 over 2 would have been a better idea. Let's use root 2 over 2. And then sine 120. So sine 120 is here as well, but sine is positive because it's on the y-axis. So that's going to be our root 3 over 2. Sine 45 is here, so that's also going to be positive. That's all good in the world. And also root 2 over 2, so known angles. So from this one, you get minus root 2 over 4. And from this one, you get root 6 over 4, is it? And then combine them. Yeah, so you can just minus if you want. Put them together. Okay, so that's quite a common exam question.
So can you do the second one, please?
Yeah. So tan pi over 12. So we need to find out two angles that make pi over 12. Rigel, what two angles did you use?
I actually tried to use the double or the tan 2 theta and try to get pi over 6.
So you used tan 2 theta is 2 tan theta.
Yeah. Because I wasn't sure how to subtract two angles that we knew. Like I guess you could do like pi over 6 minus pi over 12, but then you'd have to get that pi over 12. And then
What about pi over 3 minus pi over 4?
Oh, well, never mind.
Yeah, work for us.
I just didn't think.
So pi over 3 take away pi over 4. They're both known angles, so that's fine. Then we can use the tan compound angle identity, which is this one. Okay, so
why do you convert 10 pi over 12 to 10 like that?
why did we do what? Why did I change it to this? I want to make pi over 12, so I need to think of two angles that would subtract that I know to make pi over 12. So remember this if you want to have a common denominator, this is 4 pi over 12, and this would be 3 pi over 12. If I subtract them, I make my pi over 12.
Okay.
Okay, so I was just trying to think of two angles I know for sure to make pi over 12. So from here, then I use that identity which says tan A, so tan the first one. This is minus, so it's going to be minus tan B, minus tan pi over 4, all over 1 plus tan pi over 3, tan pi over 4. So tan pi over 3, that's the one where sine is winning, so that'd be root 3. Tan of pi over 4. What's tan of pi over 4, Malika?
1.
Yep. So minus 1 all over 1 plus tan root 3 again. So that's tan pi over 3, which is root 3 again, and that's still 1. Okay, and we can calculate all that out then, and you end up with, what do you end up with? You have 4. No, that's jumping too far ahead. You end up with root 3 minus 1 all over 1 plus root 3. Now I need to get rid of one kind of a surd in the denominator here, so I'm going to multiply by 1 minus root 3. Or something like that, some equivalent like that, I think. Is that what you guys, hopefully you did that?
Yeah.
And then you end up with 2 eventually, so I've skipped a line or 2. This is the final answer. Or, yeah. Or 4 minus 2 root 3 over 2, and then do it. Okay.
Okay.
Yeah.
Why did you multiply by 1 minus negative root 3 or 1 negative root 3?
Okay, so to get rid of a surd in our denominator, so this root 3, you gotta multiply by its conjugate. So 1 plus multiply by 1 minus. So if you multiply above and below by the same thing, it doesn't change the fraction. So I can do it out. So I'll do it over here. Root 3 minus 1 times 1 minus root 3 and 1 plus root 3 times 1 minus root 3. So I would have thought you would have seen this before. On the numerator, you can do each bit separately. Root 3 times 1 is root 3. Root 3 times minus root 3 is going to be minus 3, I think. Minus 1 times 1 is going to be minus 1. And minus 1 times root 3 is going to be minus root 3 up here. Plus root 3 minus 1 plus root 3, sorry. And on the bottom here, 1 times 1 is 1. 1 times minus root 3 is minus root 3. 1 times positive root 3 is positive root 3. And root 3 times root 3 is minus 3, isn't it? Okay. And what happens here, and this is the beauty of the conjugate, this and this are cancelled out, and you're just left with a integer, which is fine. So what we end up here is minus 4 plus 2 root 3 all over minus 2, and then divide everything by minus 2, and we are finished. We get that.
Okay, I get it. Thank you, sir.
Okay, yeah, so that's the skill you need to know. It's also using complex numbers, removing a surd or a complex number, you multiply by its conjugate. All right, question 8, the shooter. Interested by this one.
For this one, I was like, I drew a diagram kind of, but
Yeah.
it just like I got stuck because I felt like I didn't have enough information.
Possibly. Badai, any answer for the shooter?
Is this question 8, sir?
This is question 8, Jen.
Sir? Yeah, I got 45 over x.
Oh, so x is in the answer. We want to know what x is.
I got 60.
60. Yeah, sounds good.
Oh, sorry,
All right,
sir. It's at the bottom of the
Yeah.
page. Yeah, I got 60 as well. Yeah.
Okay. Well, let's talk about it. So from the ground level, a shooter is aiming at targets on a brick wall. At the current angle of elevation of his rifle, it would be 20 meters above. The target would be 20 minutes. So the target's up here 20 meters above, I think. And that's at his current elevation. So there's our first. Let's call that alpha. All right. If he doubles the angle of elevation, the rifle will hit 45 meters up the wall. So I know that the second one is going to be 45 from there to there. Let's call that 20 from there to there. And double the angle, so that's another alpha here on top. And something like that is R. So perhaps you guys have drawn something similar to that. So Malika, that would be where I'd start with your diagram. So now it's, and X is what we're trying to find. It's down here. Okay, so if I'm looking at two triangles and this is opposite and adjacent and this is opposite and adjacent, I'm thinking tan. So let's just look at the smaller triangle, the one down here. The tan of that alpha is 20 over x, okay. And the larger triangle then, that's going to be tan 2 alpha, because alpha is alpha, and also contains x. And that's going to be 45 over x. Okay. Tan 2 alpha, then of course I can, that's an identity I know, and I can change it to tan, 2 tan alpha all over 1 minus tan squared alpha. So what has happened, what we've done here is we've created two equations with two unknowns, alpha and x. And if we can find alpha, well, we're only looking to find x, so we're going to try and find x. That still equals 45 over x. So a little bit of a rearrangement here, multiplying across, we get 2x tan alpha is equal to 45 times 1 minus 45 times tan squared alpha. Now we do have tan alpha from over here in terms of x. So we're going to do simultaneous equations by substitution. So if I know tan alpha is 20 over x, that now is got 2 times x, 20 over x, is equal to 45 minus 45. Well, tan squared alpha is, of course, itself times itself, so that's just 20 over x squared. This then is rearranged and solved. I think you get 40 is equal to 45 minus, I have it here, 18,000, I think, all over x squared. So that's just 20 squared times 45.
So would this be a non-calc question?
Yeah, probably. Yeah, it would be. Yeah. You could do this without a calculator.
I just put it as multiples, so then later on it kind of.
Oh, okay. Well, let's try and solve it this way anyway, because you're going to end up with. You're going to have to divide by 5 at some stage, aren't you? Because 40 take away. So you got, if you bring so you get minus 5x squared is equal to minus 18,000, I think. Too many zeros. 18,000. And if I divide both sides by minus 5, I get x squared is equal, well, you can divide 5 into this. I think it's 3600. Just do some division. And of course, this is a known square root, so that's why it probably would be a non-calculator question. X is 60. Can't be minus 60, of course. All right, so that is how we do that one. Of course, you could have kept it as multiples or factorized earlier as well. All right, that's migration. All right, question 9. Malika, you can answer question 9. So to solve this, I think.
For question 9, I tried to do it as a quadratic, but it didn't really work.
Okay, I think it might work as a quadratic. But did you get an answer here?
Yeah, I got 5 points.
Okay. All right. And Rigel, did you get 5 answers as well?
Yes.
Okay. Well, let's have a little look at how we do it. I know straight away. Sec squared is tan squared x minus 1, isn't it? Or plus 1. So I get this. So hopefully you all got that. And that's from the Pythagorean identities in your formula booklet, in case you're wondering. So yeah, let's form a little tan squared x minus tan x, I think equals 0. With the ones cancelling out. Which means, well, I can solve this by factorization. It's not a quadratic, well it is, but it's not a normal quadratic. 10x and tan x out of both of them, and you get f with this, isn't it? So tan x from this bit is equal to 0, and tan x from this bit is equal to 1. All right, so that's
Sir, I got stuck because I didn't know the rule that secant squared x was just equal to tan squared x plus 1.
Okay, yeah, all right, that's problem. So that's one of our identities that's there. So this is your friend. This page will be your friend come trigonometry in the exam. So
okay.
Yeah, definitely, yeah. If you're ever stuck, just refer to it and see, is there anything I can change? Yeah, and so it should be easy from here. So tan of x is 0. What angles do I get from this then, Badai?
You get 0.
You get 0? Is that it?
Oh, you want the point, sorry, 0, pi, and 2 pi.
Yeah.
Okay, so tan is 0, pi, and 2 pi. Tan is 1, so that's 45 degrees, isn't it? And it's positive, so that's at pi over 4. And where else is it positive?
5 pi over 4.
Yeah, so it's going to be, it's going to be here and here, because sine over cos, they're both negatives, and therefore they make the tan positive when you divide. All right, question 10, I think, is another show that. Oh, that's 2. Oh, it's convenient. I ran out of paper. Oh, what do I use now? Okay. Found some. Was this okay? Were you able to prove this in question 10? Show that?
Yeah.
This one was
Okay.
fairly simple.
I think so, yeah. I'll do it anyway. So we were given this, and therefore we then can just say straight away that sine theta is going to be opposite over hypotenuse, b over c, and cos theta is a over c, adjacent over hypotenuse. It then asked for, from the diagram, prove that sine 2 theta is equal to 2ab over c squared. So sine 2 theta is equal to that. So we know sine 2 theta is the same as 2 sine theta cos theta. That's a known identity as well. And what does that equal? Well, sine theta and cos theta we have here. So that's going to be 2b over c times cos theta is a over c. So we're already looking like that's it, isn't it? 2ab c squared. And the second one then, Malika, did you get the second one okay?
Yes.
Okay, I won't bother doing it. So, all right. Question 11. Oh, interesting.
So I wasn't sure how to do the part B on question 7.
Yeah.
If you know to start.
Okay, well let's. How are the other you other two guys? Were you okay on this, or was this a bit tricky? I'll judge by the silence that it was very easy. No, nothing. Malika, how was it?
I got answers, but I don't think I simplified them.
Okay. But
I got cos theta is equal to 5 over 6. Oh wait, sorry.
Yeah, I got that too.
Cos theta
Okay.
equals 5 over 6.
And I got part A and part C. I just didn't know how to do part B.
Well, part C, you can just use part B's answer, yeah. All right, let's do this. Let's get it out of the way anyway. You are looking for, I forget what the question is. Show that. Okay, well, it's a show that, so I would hope you would get it. So I think our two friends here are the sine rule and cosine rule, because it's not a right angled triangle. So 3 over sine alpha is the same as 5 over sine 2 alpha. So perhaps you use that. A rearrangement of this leads to, I'm going to call that 2 sine alpha cos alpha is a known identity, all over sine alpha is equal to 5 pi over 3, I think. Now the sine alphas are going to disappear, aren't they? This is one below and below. So 2 cos alphas is equal to 5 over 3. Divide both sides by 2, and cos alpha is 5 over 6. Voila. Part B then asks to show that using, let's say, I'm reading, show that x is a solution. No. Okay, x. So you can write x as that. So from this triangle, 3x squared minus 25x plus 48 equals to 0. Right? Do you have any ideas on this? What you might do, or?
Well, I mean, looking at it says I didn't know how to start because like in question C it says find it by using the equation, and that's where I would have started, just finding the answers in the original, in the first
Yeah,
place. Going
that's pretty
backwards,
much what you're doing. That's pretty much what you're doing.
but in the order of they put the questions, it doesn't seem like you're supposed to do that.
Okay, well, yeah, you gotta. If you were just trying to solve for x here, you would go. Well, now that I know what alpha is, I would like to use the cosine rule and go use beta here and have these two in between and use x as x squared. You can't do that because you don't have beta here, so you're going to have to either use these two sides and this angle, or these two sides and this angle. So I'm going to use the cosine rule. I'm going to use I'll use the alpha because it's easier and we know what alpha is. So I'll use 3 squared, which is the opposite side, is equal to these two sides squared added together. Take away 2 times them cos alpha. Now there's where an x squared comes from. So 3 squared, so 9 is equal to x squared plus 25 minus 10x. Now cos alpha we just found out. 5 over 6. 5 over 6, well that is going to do some cancelling out, I suppose. 2 goes into that 5 times, 2 goes into that 3 times, and that's where 25x comes from. All right, let's rearrange this, but multiply everything by 3 as I do it. I'm going to get, well, 0 equals 3x squared. Now, 25, take away that 9, is going to be 16. 16 times this 3 is going to be 48. I'll put that at the end because that's not what they want. And then I'm going to put this term in the middle. 5 times 5 is 25. Okay, so hopefully that.
Yeah, that makes sense. I did that. I just didn't substitute in cosine theta, so I had 2 unknowns and I was confused.
Okay. Yeah. All right, so you can then solve this. Is the next part. What answer did you get for the next part, Rigel? You solved it.
Yeah, it's 3 and 16 over 3.
Both answers are valid?
Yep.
Okay. All right, so we factor 3x minus 16 and x minus 3 equals 0. So x is 16 over 3 and x is 3. And of course, Rigel says both answers are valid. Anyone disagree with Rigel?
I got the same answer.
Okay. No, both answers are not valid. I refer back to our diagram. If x was 3,
Yeah.
for an isosceles triangle. An isosceles triangle, then, therefore, you would say that these two angles have to be the same then. So you would then be in sense saying that alpha down here plus alpha here plus this 2 alpha is equal to pi, or 180 degrees. Which means that we have 4 alpha is equal to pi, which means 2 alpha is pi over 2. In other words, this angle up here then would have to be 90 degrees. If it was 90 degrees, therefore, Pythagoras Theorem would apply. 3 squared plus 3 squared, square rooted would equal to 5 squared. It doesn't. 3 squared plus 3 squared is square root of 18. And square root of 18 is not 5 because we know that it should be 25. So therefore, 3 needs to be dismissed as not a valid solution. Our only solution is x is 16 over 3, which suggests that it is not an isosceles triangle, which we suspected anyway. All right, so you would lose marks if that was the case. All right, unfortunately, I have my PC group about to walk in the door, so I won't get to questions 12, 13, and 14. Any major difficulties with 12, 13, and 14? All of them? 2 of them?
12 was fine. 13 and 14, a little confusing.
I got confused with 14 and 15, sir.
15 we did the other day, didn't we?
Yeah, but I still did it again to understand. I still found it a bit confusing.
Okay. Well, I'll tell you what. Malika, how were you for these?
Not bad, but like not by myself. I had to do it with a tutor.
Oh, okay. All right. Well, perhaps I will. When do we have maths? Oh, with the practice test on Wednesday. I'll try and do a question or two and upload it along with this video, and I'll let you know when that's done. I'll try and do them out so you can have a look. But hi, Lana. Okay, I gotta go. I will see you guys. Wednesday's the practice test. I'd recommend doing the review set B, and then as a challenge for that, if you have some revision you want to do. Otherwise, just it'll be practice test Wednesday. You'll do it online, and then we'll have a look at the answers when you're in school on Thursday. Okay?
Okay, thank you, sir.
Thanks,
All right, see
sir.
you later. Bye-bye.
Thank you, sir.